I don't know about all of you guys, but as a developer, there is one thing that I don't like in my job most of the day. It's when I spend a few days, weeks trying to think about the new feature I was asked to do, trying to think about all the edge cases and respect all the constraints, the design, the user needs, sometimes legal constraints. And then when I'm close to finish, I just find out that actually someone else did the same thing not on the other side of the world, but on the other side of my desk. And even more frustrating sometimes, or as frustrating, I do something, so same story. I spend a lot of days on it. And someone else does it after me, does it better, so very frustrating. And I didn't know about it. That person didn't came to me, didn't ask for advices, so it feels like my knowledge is useless, that the time I spent on it is useless. And this is really like annoying every day. And I don't know if any of you knows this feeling. I hope so. Am I only one? Okay, thank you. Okay, and obviously, if you're in small teams and small companies, it's easier to avoid because communication can be easier. But as soon as you get in big worldwide company with different countries, then it's hard to avoid. And I'm here today to tell you a story about what happened to me. So let me introduce myself. My name is Surya, and I work for a French company named Theodo, and we outsource development of web application for any business. And for the past year, I had been working for a French bank, so very big company, many different countries, so you can imagine the problem. And we were asked to create an application that I call Project A, and which was basically a very big component that I call the incredible component because it was incredible. There was a lot of constraint on it, legal constraint and so on. And we'd spent like weeks on it until someone told us, guys, you know, there is a Project Alpha over there, and they did basically the same thing. At the time, this was us. Yeah, sure, we know about this. We went to talk to them tomorrow. So we went to see them, and actually it was basically the same component they did, like 80% similar. Design was a bit different. Some features we had, they didn't, and the other way around. But basically it was the same. And I wish I could tell you they were developing this in another country. And actually it was a team from my company developing this. So you think we could have communicated, but we didn't. So it was quite sad. And same, I wish I could tell you we learned from this, we grew better since this episode, and we didn't make the same mistake again. And this is actually wrong, because this component needed to be in many different applications for internal customers, external customers, and actually with design reworks and so on, we made it 6 times from scratch. So we're talking weeks and weeks of lost development here. And at that point, we realized that maybe there was something we could have done better. And we had thought about sharing code, but when you have it twice, you're like, okay, the components already exist, the 2 of them, is it worth sharing? Now that there was 6 versions, yeah, we had to realize that, okay, it's not that big. Well, we have 6 of them, but maybe there will be a 7th and 8th, so we have to think about it. And even just to share bug fixes or new features, it makes sense to actually try to find a way to share code. And also, yeah, we were really ashamed of what we did. So we decided to look on the open source world to see how libraries were made, because we were not used to do this. We were application makers, and we had no idea about how to make a library, how to make this work. And this was something we learned to do for the past year. And if you're a bit like me, if you're a bit like us, maybe this is something you've considered, maybe this is something you want to do. So I will try to pass you on everything I've learned so that you don't make the same mistake and maybe you can go faster than we did. A few prerequisites and a few things I want to tell you before we start. I'm not here to tell you how to make a React component. I hope I'm assuming you know how to do it, and this is not the point, actually. So to avoid any, I don't want to push you my way of coding, so I started from an application by Create React App, standards. So you have this organization. The only thing I added was this components file folder here. So I will assume that this is your application, and in there you have the components you want to share. I will not discuss that much about how to make these components, how to style them, and so on. I leave that to you. Are we good? Ready to go? Great. So the first thing we want to do now that you have this, and you have your application, and you want to share a component, is actually to make a package. You're probably very good at building your application and deploying it and pushing it to production. Actually, making a package is slightly different. I'm guessing you know this file, the package.json. So you have a lot of things in it, and mainly for an application, what we use is scripts and dependencies, basically. For a package, we might want to add a few options. So the optionals one, description, author, and license. They're not mandatory, but they're still nice to have. It's cool when you're looking at a package if you have an idea of what's in it and an idea of who did it, and if you know if you can use it for commercial purposes. And you might notice also that I removed the private key, which is the one that prevents you to publish your package in usual situations. There is another key that we need to add, which is the entry point. So when you build your application, you have one file that the navigator will read. But if you want to make a library, your package, your components will be required. And so you need to tell where the entry point of this require will end up. So to know that, we have to go a bit deeper in the build system. So if we look at the build folder, this is what we have. So we have basically 3 files because I don't really care about the .map for now. Well, not for now, I don't care at all. And redside main is something for Webpack, so we don't care about this. The 2 thing is all your dependencies, so same, we don't really care. The one we care about is this one, the main. Your application is in there, your components are in there. The only thing that I'm not happy about is all these numbers here. This is the hash. This is something that will change every time you change your component. It's very nice for Navigator. It helps them optimize the cache and so on. But for us, since we want to pinpoint one file that will contain everything, the fact that the name changes all time, it's annoying. So I had to go deep in the Webpack configuration and remove a few things. So I changed this hash stuff in there to remove the hash. And another thing I had to do here, those 3 lines, will change how Webpack builds your components. Because by default, Webpack will optimize them for a navigator. But now, they won't be used for navigator only. They will also be used by another bundler. So we use this UMG. I realize that at the end you must absolutely not see what I have here. We specify that we ask Webpack to build what we call a UMD, Universal Module Definition, or description, I don't remember. And this specific format can be used as well in navigators and in bundlers. And so once you do this, we have here this list of file, and this one is the one we're interested in, so we don't have the hash anymore, and it should be usable by anything. So now we can put this main property here, pointing at this file, and everyone that will actually call require your project will have in components everything you have in your application, so the application and the components. You have your package. Now you have to push it, to publish it. And it's actually very simple. You can call this login to NPM. If you have an account, username, password, email, and so on. If you don't have an account, username, password, and email, and NPM creates an account for you automatically. And then you publish, it will create an archive and push it. If you don't want your components to be public, which can be understandable in a company, you can either buy private accounts in NPM, or you can use a private registry server. There are a lot of them. We decided to use this one called Verdaccio, and this is something you put on a machine in your office somewhere close to you, and you can actually use it the same way you do with NPM. You push your packages in it, and they're available. So at this point, you made your packages, they're available, but no one knows about it. So you have to advertise a bit. You have to make sure everyone knows they exist. And more important, you have to make sure that everyone knows what components you have and what components you don't have. Any open source library that is pretty good, will have this kind of landing page on which they will tell you how to install, how to start, what you have, and so on. So Material UI, React, Webpack, Lodash, and many others. And this seems like a long time to do, right? This seems like quite expensive. You don't really want to spend weeks and weeks trying to build a website. And we didn't either. So we decided to use Storybook, which is a tool creating for you a web interface in which you can add your components one by one. So this is basically what it looks like. And setting this up is actually pretty fast, probably like, I don't know, within an hour and between an hour and a day at most. And then with a few lines of code like this, you can describe what your component is. So here, I'll say I have a button with this, and I give him props, which is a label, and this will display this button in the interface. So with a few lines of code, you can actually describe every component you have and display your whole library. If you have a bit more time, you can even go further. You can add what Storybook called knobs, which are small functions there that will create an input in the Storybook interface. So here I added text and 3 booleans for the flag. And now your component is actually playable. Someone can actually check or uncheck the different checkbox to see what happens when I put this prop and don't put that one. And you can actually try out, okay, this doesn't look good. It's good on my screen. Let's say it's a projector. And you can actually see what will happen when you put this prop or that prop. This is very interesting for users because they can know what you have and how to use it, and it's also interesting for you as a developer to test your component. And finally, there is something that is called action that you can use to test callbacks. So you can define that, okay, on the on-click of a button, I actually want to know when someone clicks on the button. I want something to happen, and this will add an action tab in which you will have the, okay, someone click on this button, and you have the object here that was sent, which is a mouse event here. So by just doing this with one line of code, you can also test your callbacks. So right now, what we have a package that is sent and that anyone can download. You have your store where your components are displayed, available, and everyone can know how to use them. The next thing you have to do is to try to make your library bigger. Encourage contribution, because remember, the purpose of this is to make sure that when someone does something, the others know. So it's not just about you, it's also your neighbor, your colleague over there that made an incredible component and you want it so bad. So please put it in the library. And it's actually hard to encourage this because it's not their project, it's your library. I'm not sure if I'm willing to put my foot in it. So you need to encourage and you need to make sure that there is a clear contribution process. Because if you're going on an open source repository and there is nothing about how to contribute, you're not even sure if contributions are welcome. And even if there is something to say, hey, you can contribute, if you don't know how to install the project or how to test things, well, it's quite hard. So we had a big list of what to do. So yeah, it's quite big, but because it's quite detailed. In all this, we wrote how to install this, how to run the test, how to make a commit, and a few aids about how to actually work with our library. The second thing you need is to make sure that you explain all your quality standards. What level of test coverage do you want? The commits that they have to make, small commits, big commits, very cut, what kind of commit messages, everything they have to know to avoid having their pull request rejected 3 times a day. And why is this so important? To do this, well, how can they know this? You can put it also in the documentation, and you can also use the pull request templates to help them never forget about what you want. And why is it so important? It's because on this library, your quality standards must be way higher than usual. Because every flaw, everything that is of poor quality here, will have an impact of all the users, of all the applications. So you must make sure that this library is the best thing you ever had, the best thing you've ever done, and you make sure that the contributors will follow these rules. And the last thing, be ready to answer questions. Be extremely, extremely there for your users. They will have problems. They will have questions. They will have things they won't understand. And by being there, they will feel safe. They will feel secure. They will actually be happy to contribute because they feel there is humans behind this library. And besides, you will actually immediately see what is wrong. Where is the biggest pain point in working for me? And for instance, one of the situation we had was this one. When you're working on your project, you want to change your component. Fine. You make a test. It works fine. You test your project, your application, and it works. If you want to change a component in the library, how do you test this on your project? You can make a new package and install it and then run, and then if it doesn't work, you have to come back to the library, remake a package, and so on. That's quite long. And they complained about this a lot. Until we show them that there is something that is called npm link that actually creates a symbolic link between your project and the library, and the iterations become much faster. But we had other problems because suddenly the dependency of the library were sometimes not aligned with what there was there. So there were conflicts between dependencies and peer dependencies missing. And there was really, really a lot of issues. So we wrote a big documentation about how to properly do a link. And you can see that the prerequisite part is actually bigger than how. And we could do this because we were actually very present with the users. Every time they had an issue, they knew they could come, and we could try to fix the problem they had and try to understand, and then we could do this. Once you have a lot of contributors, a lot of users, you will want to protect their users, the end users, because it's something that something that happened to us too, a lot actually. It's that when you're on different projects, you can basically do whatever you want. You want to change the component API, you adapt your application, and it's fine. Here you can see that there is 2 incredible components, but the props that they take are slightly different. But it's okay with everyone. But if you do this here, and that suddenly project A decides, okay, let's remove a prop because it's not relevant anymore. Well, 100% chance that other projects will break because they still expect the old API at first. And project A is happy, but all other projects will have to deal with, I don't understand, I updated this package and then suddenly everything is not working. I don't know why, I don't know what to do. And seriously, if this happens every day, I'm just gonna make my own component. This is called breaking changes, as you probably know, because if you've ever updated a dependency, you know what this is. But what you might not know is how easy it is to introduce breaking changes. It was so easy that our colleagues didn't pay attention at all to this. They keep changing the API of the components like twice a day without noticing anyone. So to avoid this, we used Flow. So we were actually using Flow on our project to test to make static type checking. I won't go into details on this because there is another talk about this later today. Sorry, so I will let you see what's happened there. But basically, what we did with Flow was to describe the API of each of our components to make sure that they were used properly. And the change that we did to cover those breaking changes problem was to export those type in specific files, like this. So here we stated that our module shared component will have an incredible component in it, and that the incredible component would take these props. If someone were to change the props of the component, they would have to change this, because otherwise Flow would break. And that's when we used a second tool, Danger, which is a tool to automate code review. And his job was to check actually if those files changed. And if they did, Danger would write a comment on the pull request saying, hey, you changed this file, probably you introduce a breaking change. You might want to check. And this was enough for developers to realize, hey, okay, maybe I did something, I will check. And then they could actually specify it in their commit, saying, okay, I did a breaking change. This is what changed. This is what you have to do to correct. And this would appear in the change log. And the change log would have this major bump saying there was a breaking change. This is what you have to change. And this way, other users could first know and expect the breaking change and know what to do about it. Which brings me to the next step. Split your packages. Why? Let's go back to this breaking change things. If you have one package with, let's say, I don't know, hundreds of components, you make one breaking change in one component. The whole package is bumped with a major, and well, everyone is now aware there is a breaking change on this package. So all of them will try to find out, okay, is there something I have to change? Which component is impacted? And there is probably one person actually using the component that will be happy that he was warned and that he could do something about it. But for the others, it's a waste of time. They're not using this component. So they're not really happy about the fact that they had to check, especially if you have 100 of components and that the library is quite active. This might happen 3 or 4 times a day. So all of your teams are now spending time to see if they have to make something about breaking changes. So to avoid this, we decided to split our components in different packages. And we use for this the atomic design, the principle of atomic design. So how does it work? Atomic design is an analogy with everything around us, everything around this room. So at the root you have atoms, and when you get atoms together it makes molecules, and molecules together make organisms. I'm sure biologists would find more layers between molecules and organisms, but we don't really need them. And we use this to decide that we would have 2 small components that would be elementary components, like the smallest one we could want, and then use them to make bigger components, and then again use them to make bigger components. So for instance, we could have in atoms all the UI components, so here date picker, and use those date picker to create a form, and then use this form to create a web page. And so that's what we did actually. So all the atoms are UI components, small UI component we use to create bigger things. And how does it save us time? Well, now, if someone actually introduces a breaking change here, all we have to do is apply a fix on this one. And the last one, the organism doesn't even need to change, because he's still using this component, which didn't break. So this package, the atom package, will have a major bump, but the molecules will have just a patch, and the organism won't change at all. So if we go back to our previous users, well, there will still be some of them that won't maybe be happy because they had to check stuff and they're not using this component, so they don't care. But this one is happy, and those, they were not even bothered. So you reduced the impact of the breaking changes. At the max of this idea, you might want to say, okay, let's do 1 component per package. But you might have a lot of packages. And it might be harder to handle. And beside, there is, well, not beside, but there is another problem with this cut. If now, instead of a breaking change, someone just made a bug fix on a component. In the previous version, where everything was together, well, the bug fix would have automatically spread through the components. And it would have been fine with just one version. There would have been a patch over there, and it would be fine. But now, with this separation, with the split, this one is fixed, but this one still has the bug, and this one still has the bug. And so if you had 3 packages, it's fine, but if you have like 10 packages, 15 packages, 25 packages, it can become a bit harsh to check, okay, I made a fix on this one, so this one bumped, so I have 5 packages up there to update because they depend on this one, and then those 5, there are 10 that depend on this one, so I have to update all of them. So to avoid having, so we don't want to do this manually, so we use Lerna, which is a tool that is made for this, is made to manage mono repository, and we put all of our packages into the same repository, and Lerna actually does this for us. When you bump this, Lerna will actually check which packages depend on this one and will bump them. And same for all the dependency. So all of this is done automatically by Lerna, which is super convenient. And last thing, I'm guessing I'm not the only one that has ever been on a website with their phone. And I'm guessing I'm not the only one that has ever been waiting way too long for a page to load. Even sometime gave up. And even if it's not, even if JavaScript is not the main responsible, it's actually a part of it. It's a bit of a culprit. And with what I told you so far, we have one problem, a big one. Let's imagine I create this very small library with 2 components, a small one, a light one, and a heavy one. Basically, the light one is a text, and the heavy one is full of images. And I create, out of this, 2 applications, one with a heavy component, and one with a light component. Other than those 2, the applications are exactly the same, just displaying the component. My guess would be that the second application is lighter, but actually it's not. It's not because at first I told you that we should build this library using UMD so that it would be compatible with Navigator and stuff. Remember those 3 properties over there. And the thing is, here, when your applications are bundled, the bundler doesn't know which part of the library you're using or not. So everything just ends up in the application. So for here, the impact is minimum, not so hard. But here, the user is actually downloading hundreds of the hundreds of images that are in the heavy component, even though they don't need it. So how do we avoid this? The only way to avoid this is by using the Webpack and the bundler capability of tree shaking. And to do this, you need to have what is called ES modules within your component. So I don't know how you import export. If you use require and stuff, then you will be blocked there. But if you use this import export in your code, then you're good to go. And actually, the easiest way to have ES module and to allow tree shaking to your users is by doing this. Replace the main part with your source instead of the bundle. It's the easiest, but it's not the good way to do it. Why is that? The first one, not every bundler is able to read ES modules. For example, Browserify doesn't. Second, we said at first that you wanted a part of your code to be readable by a navigator. And not all navigators are able to read ES modules, sorry. And another reason, if in your code you're using like very advanced JavaScript features that would need transpiling with Babel, with this, you're forcing your users to make the transpiling for you. So they have to adapt their Babel configuration based on what you have made, based on your code. So obviously you should not do this, and actually I advise you to use rollup. Another try I made was to use directly by Babel. So transpile everything with Babel, then put it in another folder and send this. But to be honest, I had trouble with the images and CSS and all of the stuff. So I advise you to use rollup because it will help you handle everything that is not JavaScript, and because you can actually still make those 2 outputs, the ES modules and the universal module definition that you need for the navigator. And with that, last, you need to still add something to your package.json. which is this, the module key. This one is only read by bundlers that actually know how to handle ES modules. So browserify will read main. You can send main to your production server for your application. And those who know how to make tree shaking, they will use the module and they will be able to make light applications. So to sum up, if you want to make a library from an application, start by thinking package. How will you organize your components in different packages that are small enough to avoid a lot of breaking changes impact, but still not too small because you don't want to have the hassle of handling hundreds of packages. Make sure that you build them properly so that they stay light and they don't have a huge impact on their user's application. And then distribute them and decide if you want to do it public or not. Advertise a lot. Everyone should know what components you have and what you don't, because this way they might actually use what you have, and they might also want to share what you don't. And make sure that anyone who wants to contribute is helped as much as possible so that they can actually improve your product for you. And finally, protect your user from the breaking changes, because seriously, trust me, it happens very fast. And if you do all this, I promise you that you will have the best library ever, which you could then spread to your team, company, department, worldwide, open source it, and whatever. Thank you for your attention. And as I told you, I'm open to questions. So if you have anything to add to this presentation and so, I'm open to it. Thank you.